Welcome to Wes Explains Best. We're doing a Pythagorean theorem challenge today on Khan Academy. Let's get started. Ryan is putting a clothesline in his rectangular backyard. He wants to put it in between two trees on the edge of his property. He has measured his property and made the sketch shown below. What are all the lengths listed? Where all the lengths listed are in meters. Okay. What is the smallest length of rope that Ryan could buy, which would stretch from one tree to the other? Okay, so we got the two trees there. Essentially what we're trying to find is this length here. Let me just make it in blue. Okay, so we're trying to find this length, and we have some information here. Now, obviously this is a Pythagorean theorem challenge, so we need to use a squared plus b squared equals c squared in some capacity. What is that capacity? Well, we have to draw a right triangle. Okay, it's all about right triangles, Pythagorean theorem. We can easily do this. Now, how do we do it? Well, let's draw a triangle this way, okay, one of the legs, and then draw the other leg this way. So now we have a right triangle, okay. Now, we need the measurements. We're looking for this distance here. We'll call it C, because that's the hypotenuse opposite the 90-degree angle. What we need here is the other measurement. So we know this is 20, okay? This needs to match the top since it's a rectangle. Now we just need to know this side right here. If we know this whole big side is 25, and this little side is 10, then to find this smaller section, we just do 25 minus 10 to find that little measurement there. And that's going to be 15. So that little measurement here is 15, because 15 plus 10, okay, so let me just show you. 15 plus 10 is going to equal 25. Okay, so then we can redraw, if you want, you can redraw the, wrong thing. We can redraw the whole triangle if you want, or just put it right into the formula, which is 15 squared plus 20 squared. And this is going to be equal to c squared. Okay, so then we add these two together. 15 squared, 225 plus 400. Okay, and that's 625. 625 equals c squared. Take the square root, and we're going to get 25 equals c. So c equals 25. 625. 25, right? Oh, yeah, okay. There, I was looking for a hide scratch pad. 25 meters. No, 25. So check it. There we go, next question. All right, a builder makes drain pipes that drop 1 centimeter over horizontal distance of 30 centimeters to prevent clogs. See the diagram below, which is not drawn to scale. A certain drain pipe needs to cover a horizontal distance of 700 centimeters. Okay, so this is the ratio we're going to be using, this 1 to 30 ratio. A certain drain pipe needs to cover a horizontal distance of 700. What is the length of this drain pipe? Okay, so a couple different ways you can do this. This is like a similar triangles problem and a Pythagorean theorem problem. Okay, I think the easiest way would be to start by finding this drain pipe distance here. Okay, this is the ratio of the small one, so we need to find that C first. In order to find that C, identify the legs, 1 squared plus 30 squared, and that's going to be equal to C squared. Okay, so then we have 30 squared is 900. And then we have plus 1 squared, which is just 1. So we have 901. Ooh, boy. 901 equals C squared. Okay, so we take the square root of that, and we're going to get 30.0, we'll call it 167. Ooh, that's not what I was hoping for. Okay, so we know this is 30.0167. Now what we're going to do is we're going to make a ratio here. This bottom length to that blue length, okay? So this bottom length to that blue length, we're going to create a proportion. So we're going to compare the small one to the big one, and we're going to compare the hypotenuse to the bottom leg, okay? So our hypotenuse is, for the small one, is 30.0167. For the bottom leg, it is 700. No, 30, sorry. For this, we're doing the small one first. Yes, that color. Okay, thank you. 30, there. Equals the small one, excuse me, now we're on to the big one. Okay, I should have labeled that first, big, small. And now we're talking about the blue leg. The blue leg, the hypotenuse is L, that's what we're looking for, over the bottom leg, which is 700. So we're going to cross multiply here and then solve. So we get L times 30, 30L, equals, and then we do 700 times that decimal, okay? And I just leave it stored on my calculator. I think that makes it easier. So I get 21011.663. I'm going to divide that by 30 now to solve for L. So we get 700.3 rounded 9. What's the nearest tenth? So 3/8. That's going to round that to 4, 700.4 centimeters. All right, next question. Okay, I don't know if we'll be able to finish in time, but we'll definitely do one more. Okay, so below is 15 centimeters. Okay, Rubik's Cube. Every edge of the pyramid is 15 centimeters long. Okay, so we know this is 15 centimeters. The pyramid's height is 12.2 centimeters. Okay, so this is, okay, got it. So this is 15, and we're trying to find this, let's see what we're trying to find. I don't know yet. What is the R radius of the pyramid? Okay, so we know that we have a couple different things. One, we have a bunch of different triangles going on here. So the first one is, let's take a look at this big face here. We know this big face, this triangle right here, these are all 15 centimeters, okay? It says the height is 12.2. Well, actually, we don't need that much. We have, this is 12.2 centimeters is the height. Okay, this height is 12.2. We know this side right here, shoot, I should erase it. We know this height right here is 15, and we're just trying to find R there. So 12.2, I'm just double checking. The pyramid's cube is every triangle base pyramid, every edge 15 centimeters. The pyramid's height is 12.2. The triangle shown dashed lines as a right triangle. Okay, so I'm thinking there's more to it, but I don't think there is. This is going to be our C. That's our hypotenuse. 12.2 is a leg. And then we have R is its own leg. So we're going to do plus R squared. I think there's got to be more to it than that, though, right? I guess not. Okay, well, let's try it. So we're going to do 15 squared is 225. Okay, we're going to subtract 12.2 squared. And we get 76. Okay, so what I did is I got, I subtracted 12.2 squared for both sides. And I get 76.16, and that's equal to R squared. And I just take the square root of that. I feel like they did all the work for us. I'm scared this isn't the right answer. It says around to the nearest what? Nearest tenth. So I got the number 88.73. So that's going to just stay as 8.7. We'll test it out. What do you know? Okay, we have time for one more. A flagpole broke in a storm. 7 meters are sticking straight out of the ground where it snapped. Okay, 7 meters sticking out of the ground where it snapped, but the remaining piece has hinged over and touched the ground at a point 24 meters away horizontally. Okay, so here's my flagpole. Here's our distance here that it fell. That's 24 meters away. We're trying to figure out how tall was the flagpole before it broke. So we need to find this. If you recognize this is an automatic triangle, so what we're going to do is 7 squared plus 24 squared. You guys should probably know what it is if you guys have been keeping up with some of the automatic triangle stuff. But this is going to be equal to this length here. We'll call that C squared. So once we do 7 squared plus, we get 7 squared. I might as well do it out. Plus 24 squared. And then that's 625. 625. And we just take the square root of that. Now, don't put this as your answer. This is 25 equals C. But we have to do 25 plus the 7 for the total height of the flagpole. So what is that, 32? 32 meters. Did I write that out? Yes, that's the total length of the flagpole once you straighten out that thing like that. Okay, flagpole. 25 plus 7, 32. That's a tall flagpole. All right, that's all there is for this challenge. Hope you guys enjoyed this video. Good luck with your Khan Academy. I hope to see you next time on West Explains Best.